parallel and perpendicular lines show up constantly on the SAT math section. The rules are simple, but the test loves to disguise slopes inside different forms. If you can read slope quickly and apply one parallel rule and one perpendicular rule, you can lock in points without drama. Parallel lines never meet, so they rise and run at the same rate in slope-intercept form. That means the m values match. Perpendicular lines meet at a right angle. Their slopes are negative reciprocals, which you can also remember as multiply to -1. Visually, parallel lines look like copies shifted up or down. Perpendicular lines look like a corner, one steep and one shallow, when slopes are not 1 or -1. Here is this perpendicular picture for the same base slope 2/3. Perpendicular slope is -3/2. Flip and change sign. Keep the negative reciprocal rule tight. Flip the fraction and multiply by -1. If you skip either piece, perpendicular problems fall apart. Next come 3 worked examples. A fast parallel slope red, a full perpendicular equation through a point, and a reasoning check about 3 slopes and a right angle. Example 1, easy style. A line is parallel to y equals 2x plus 1. What is its slope? Parallel means same m. Here m equals 2, so any parallel line has slope 2, even if the y-intercept changes. Example 2, medium. Find the equation of the line perpendicular to y equals 3x minus 2 and passing through the point 6, 1. First read the slope of the given line. Here m equals 3, so the perpendicular slope is -1/3. Now use point slope form. Y minus 1 equals -1/3 times the quantity x minus 6. Distribute -1/3 times x minus 6. That gives -1/3 x plus 2 on the right, because -1/3 times -6 is 2. Add 1 to both sides. The final slope-intercept form is, equals -1/3 x plus 3. Quick check. 3 times -1/3 equals -1, and -1 times -1/3 equals +1/3. Not needed here, but the multiply to -1 idea still holds for the original slope and 3. Example 3, harder reasoning. 3 distinct lines have slopes to -1/2 and 1/4. Do these lines necessarily form a right triangle when they intersect? A right triangle appears when 2 sides are perpendicular. So look for a pair of slopes whose product is -1. Multiply 2 and -1/2. You get to -1, so those 2 directions are perpendicular. If the 3 lines are not parallel and they intersect in 3 different points, the triangle formed has a right angle between the slope 2 line and the slope -1/2 line. Notice the third slope does not need to be perpendicular to anything else. One right angle is enough for the triangle to be right. Common mistake: students remember reciprocal but forget the negative, or they flip without the negative. Perpendicular means both flip the fraction and switch the sign. The correct perpendicular partner is -1/3. 3 times -1/3 is -1, which is the clean test. Set pro tip. Before you compare slopes, rewrite every line in y equals mx plus b whenever that is reasonable. Standard form can hide and solve for y first, then read the coefficient of x as the slope you compare for parallel and perpendicular relationships. Let us recap the essentials. Parallel lines share the same slope. Perpendicular lines have slopes that multiply to -1, which is the same as negative reciprocal. And when in doubt, convert to slope-intercept form so the slope is visible. Practice more on NovaMaths.